Good afternoon, everyone, and this is the Teaching Learning with Technology Symposium continuing this afternoon, organized by the Finger Lakes Faculty Development Network. Those of you who have been in this room earlier today, you've heard the spiel already. A group of faculty center directors, academic technologists, faculty developers from Syracuse to Buffalo, and campuses in between. Contact information is on the doors to this room if you care to learn more about us. And without further ado, I'd like to introduce Rob Garrick of our IT.
Good afternoon. My name is Rob Garrick. I'm from Rochester Institute of Technology, and I want to talk to you about what we did utilizing tablet PCs in a technology-rich learning environment. But I also want to point out how we kind of mapped the instructional domain and the technology domain. It's not just technology for itself, and you've heard it all today. It's what am I going to use it for? What's the outcome that I'm looking for? Again, what we're trying to do is enhance student learning. So from an agenda point of view, I'll go through the problem statement. I mentioned to some of my colleagues from engineering, we probably know the problem, but not all of us have seen the problems that we're having in engineering education. I'll go through kind of the education research, the literature review of what we found. Again, I'll apologize for those of you in education. Being from the engineering side, this was like, wow, this is great. You might go, yeah, we knew that for a long time. We just don't tell the engineering guys, but we've known this for a long time. Then what we did to mapping the instructional and technology domains together, what our methodology was, specifically kind of the blended experiment we ended up doing, and why we did it. In my presentation, I'd be glad to share it with anybody. I didn't bring a whole bunch of copies because I know most of you probably want it electronically, so give me a card, give me your email address. I'd be glad to send you electronically. There's a good amount of words in here and my references. I'm not going to go through them all, but when you get it, I'd like you to have a document that kind of stands by itself so you know what was going on and not. I think he said the reference was so that you can build upon it, or if you're interested in collaborating. What our findings were, and some examples of what we did in the environment, then what are the next steps we're looking for. So problem statement. Significant portion of, in engineering, lose interest in our programs. We unfortunately have a graduation rate that can range between 10% and 40%. Okay, that means 60% to 90% of the students at the end of the program are not there. Which, if you think about engineering and admissions, we spend a lot of time. We're all in these institutions and colleges and universities that are recruiting, and right now we're asking deposits and doing open houses and all this work to get students interested in what the fields are, and then 60 to 90% of them aren't there. So to me, wow, that's not a good thing. Engineering programs typically have the longest time to completion in undergraduate degrees. Issuing is especially troubling because of all the screening we're doing ahead of time. SAT scores, we're looking at all these things. Still, we have a huge time to degree. In addition, typically when students leave engineering programs, they don't come back. Typically students in other programs don't come to engineering. And I don't know whether they hear something on campus, but we celebrate, hey, we got a transfer student. And it's pretty rare. For some of the studies, they point out why that attrition occurs in the first 3 years. So sadly, studies show primary cause of this high attrition, engineering technology programs, environment, unmotivating, unwelcoming. It's not because the students don't have the cognitive potential to do the work. It's because the environment, the learning environment, they feel is unwelcoming and unmotivating. So it's kind of, wow, okay, what are we going to do about it? So that's what we came into it from a problem statement point of view. Pretty big problem. Typical introductory engineering classes. This is statistics from pneumatics and hydraulics, which is a second-year class, first semester, second year, so fall semester students coming in. We have about a 22% D's, W's, or F's. So 22% of the students are getting a D, which means they barely passed. They're probably not going to do well in the next class, in the sequence, because they don't have the concepts. Some of our classes are C to advanced, so they wouldn't be able to advance, they got to go back and take it again. They're withdrawing, which they're either going to come back and take it again, or they're off to another program. They're getting an F, again, we'll see what's going to happen, but they may be off to other programs. You can see at times it ranges, the best we could do maybe is 15%, the worst is up in the 40s. So, again, I think From an engineering technology point of view, those of us that are engineering educators would say, yeah, that's the introductory engineering classes. They're difficult, not all the students get through, even though they have the academic potential, they're not achieving what we want them to do. From an administrator point of view, I just point out, those of you that are administrators, 504 students over this period, it's 115 students that have to retake the class. How many sessions do you have to schedule? How many classrooms do you need? How many more instructors do you need to be able to teach all those? So it's not just a student problem, it's not just an instructor problem, it's an administration problem. So what do we find from the research? We look back in some of these seminal papers, interactive engagement is the guide that we need to introduce into these classrooms. Some of these studies, 6,000 students, interactive engagement, designed, heads are always on, hands-on activities, but having these constantly thinking, hands-on activities in the classroom. Many of these look at what people have talked about, taking some of the traditional lecture environment, pushing it off, inverting the classroom, where the lecture content may be outside the classroom. The traditional engineering, go do 50 homework problems and turn them in next week, is inside the classroom. So actually trying to reverse or invert the engineering classroom. What are we trying to do? Create an engaged, cooperative learning environment. Again, this is not new for engineering education. It's been around 20, 30 years, but it may not be typical in all areas. Some classes do it, some classes might not. Again, what we're trying to do is study how can we get this kind of across the entire curriculum. Some of these researchers documented what the approaches are. Cooperative learning, group problem solving, improved problem solving skills are the big things we're trying to hit in this environment. Okay, so we know what the problem is, we know what we're trying to do, now what do we do? So what we ended up doing is looking at these domains, an instructional domain of what's our objectives, what's our tasks, what's our assessment activities. What are we trying to do from an instructional point of view? So my interactive, my group problem solving on this side. What's my technology domain? What can the technology do? We were looking at tablet PCs, multiple displays, all these different tools we've heard about today. What can they do? Presentation tools, sharing tools, polling tools, interactive tools, group problem solving tools. What can I do? So I got these two domains. How do I map them together? So just an instructional domain, what it would look like in terms of content, how I want to do it, by what means, and animations, and images, and assignments, and graphical work, and questions, and student work. How does that all break down into what I want to achieve as an instructor to achieve my course objectives, my educational objectives, my program objectives of what I'm trying to do. Then the technology domain. This is for the tablet PC side. With digital inking and written inputs, how it permits me to write or draw or mark or sketch and brainstorm and collaboration, what it can do, and then mapping those together. Okay, I want to get this educational objective, this technology piece, how do I map these together to see what technology tool do I want to do to achieve my objective? So based on that, we put together some studies. Our methodology. We looked at a number of kind of a blended experiment approach. And I'll try and point that out. I'm trying to think of what's the best way to show it. But I'll point out what we did is, for some classes, we had the traditional approach of didn't do it, didn't do it, didn't do it. Okay, introduce the treatment, your experimental condition, and see, okay, how does this group respond to previous groups? Obviously, one of the difficulties with that is you're time dependent. So is the class last semester, last year, the same as the class this year, this semester, that are getting the treatment conditions? Can I truly compare that, or has something happened in their preparation classes, in their introductory classes, that's going to skew my results? But we did some of that from a classical point of view. We did some where we split the classes. Okay, 2 get the treatment conditions, 2 get the control. So we're not time dependent. They've all had the same introductory classes. And we can say 2 are in this environment, 2 are in this environment, compare their responses, how they do, how they like it, how they do on standardized tests, how they do on standardized content. Then we did something that I haven't seen a lot in the literature, is split the class. So Monday, we're going to be in this technology learning environment. Wednesday, we're just going to be in a computer lab. And then we're going to switch every week back and forth. So every Monday, we're in this technology-rich environment. You have tablet PCs and multiple displays, all of what we're trying to do for mapping. Wednesday, we're still in a computer environment because I want to protect from the technophile effect of, wow, you just put a computer in front of this generation and their eyes will light up. No, let's put computers in front of them in both environments and see, is it the exact tools that we're utilizing in this environment. So we did kind of a blended experiment. We did quantitative pro-surveys, we did focus groups at the end. So I'll show you some of that, of what the results were. For our results, 2-to-1 ratio, more likely to take notes, utilize the notes in a tablet PC interactive environment. Why? You know, my questions of why. Is it because as an instructor, I'm presenting the information. I am digitally inking on my tablet. It's now on everybody's tablet. So they just have to add the material that they need. They don't have to be the Xerox machine copying everything down that I write. They can just add and think, and then add the extra notes they want. Their notes are obviously organized, neat, saved on a server, fully retrieved. Not like maybe the typical notebook student that, what are your notes? Whatever. I lost them in the dorm, I spilled coffee on them. No, they're in the server, they're time dated, they know by lecture. They have all of my notes in it, they have all of my presentation information, they have all of their notes in it. So, yeah, maybe that would make me more likely to take notes and use them. More thorough and better comprehensive material. Well, obviously your notes have everything in it. The thing they commented on in the focus group was they liked the ability that they wrote something down on slide 6 and it's there on slide 6. It's not something they wrote in their paper spiral notebook and then they got to remember, where was that from? I know it was in this presentation if I got the presentation, but I don't know exactly where. So we've probably all done it, taken notes. I know I do it all the time. You take notes and then you go, I don't remember it now. It lost something. In the time it meant something, but now I lost it. So help them learn the material. They felt that material was better than just watching the instructor complete problems. They were doing group exercises, doing more group work in it. They recommended the environment, 94%. You know, almost everybody has a high preference for this environment over just having computers in front of them. Why? Being able to write on their notes as opposed to typing. Typing may not be quite as natural as just scribing on a tablet to have your notes. So focus groups, again, very high positive comments on active learning, high positive comments on learning, engagement, preparation. This was all done by an independent evaluator that reviewed our focus groups. General comments out of them: really felt motivated and involved in the class, immersed in the material. They'd like to see mistakes. I could sign a problem out, everybody does it, suck them all back in, let's look at them, throw them up on the board. That one's good, that one's not good. They'd have all those good and bad examples, because engineering problems you can solve different ways. They'd have all those in their notebooks. And they liked it. They liked to see good solutions and flawed solutions, and they liked the feedback immediately. Some of the comments from the focus group was, boy, this is a lot better than handing in a quiz and getting it back in a week from a folder. And what do they look at? The grade. And throw it out. They look at the notes you put in there? No. Look at the grade, throw it out. But when you get it back, turn it in, and go right, the evaluation's 5 minutes later. Wow, that's in context of how I did it. Learning, direct statements of how much they learned. There were fewer comments on it. We didn't ask them directly learning questions. In this initial work, we weren't working with a cognitive learning scientist. We hope to in the future, so we can really kind of peer in and see how is the learning happening. Engagement, they like being active in the class, distinguished from active learning. All but one of the comments supported the tablets as increasing the learning environment. What did we do? So just to give you some examples. How we delivered content, how we used polls and group work, how we did laboratory practices for them, and then how we did a little competition. Multiple displays. We ended up with multiple displays. Why we liked it is, especially, we're talking about for our deaf and hard of hearing students, or basically any student. We've all been in the meeting where the current slide's up, you look down, you write a note, you look up again, and the person's on to the next slide, and you miss something. Now, current slide just slides over. So you can always see the previous slide. Especially helps, we think, our deaf and hard of hearing students, so that they're a little bit delayed in getting the information to the interpreter, and the slide's not moving on them. I can also bring in auxiliary video support material and reflect back on the equations and the derivation of them without having to flip screens all around. How I could pull in group work. This is group practice work. We had students solve these. Again, they can be immediately sucked back in and reviewed in the class, or pulled in, I'll grade it later, graded, sent back to them electronically. They all have it. It's not lost. They can use it for review later. Practicing setups or laboratories, we brought in pictures of the devices, and then they would, using lines, connect devices. So how to give them practice before they move into labs and then get delayed on setup and the explanation of equipment. Competitions. They really like this, and it was really helped. How's the technology? It helps my efficiency. As I'm looking at it, I only have my 15-minute time slot. How do I get that material in? So utilizing competitions, setting them up in blue team, red team is what we ended up doing with different groups. Normally in our engineering review session, I'd be up there on the whiteboard, scribing my heart out, solving problems. They may be copying them down. Probably not asking any questions. The guy who dares to ask a question hears the scorn from the others of, or, you don't know this? We don't know this. So the environment, the anonymity, boy, that adds a lot, especially for possibly underrepresented groups. But encourages learning when it's a team effort. So here we assign different problems to each group. So I got 6 times the problem solved than I could do myself. So I got a lot more efficiency, went through a lot of problems. They graded each other's problems. They got really good at being picky. You know, we all see the same mistake over and over again. And you get out your pen and you're writing and thinking, is the student ever reading this? Well, when they're grading somebody else's, after a few rounds, they're getting really good at, oh yeah, we gotta make sure we have units. We gotta make sure we have the significant digits. We gotta make sure we have all these common mistakes. Otherwise, the other team's gonna give us a low grade. And we know at the end, competition, we wanna win. You offer some extra credit points, you offer some food, something, but they're really not going for that. They're driven by, hey, it's the competition. So we're able to solve a lot more problems, do many rounds of competition, and at the end, they're all in their tablet, they're all in their workspace. They have tons of solved problems by good ones and bad ones that you reviewed, marked up quickly, and they can go back and review. And you also can provide them the solutions. So they have a great review packet as opposed to you trying to scribe away and get as much done as you can. Next steps. What we're looking at is cognitive research studies, trying to get cognitive learning scientists to work with engineers. Right-brainers and left-brainers actually trying to share together to look at, well, okay, what are the needs of the engineer in 2020 in terms of solving complex problems, international growth, all these things that we see getting pushed into the engineering curriculum, innovation. Okay, add that. Well, that's good to add that. I only got 50 minutes, and I have the content I have to. Well, and then there's a new this and a new that, and you only got a certain time period. So how do you squeeze all that in? Then obviously all the research going on how people learn, but integrating those two together, hopefully to get even more benefit and understanding of the environment. I went through a lot of stuff quick. I didn't get to sign yet, so we're pretty good. So I want to see questions in terms of, anybody have this question? Anybody have experiences? Anybody have differences in what they've seen in this sort of environment?
How do you deploy the tablets? Are they all right in the room, or?
What we had is we had a room. The room has 25 tablets in a cart. Once the students get trained in the first 2 sessions, they come in, grab their tablet, unplug it from the cart, which has been charging, sit down at their table, pop open their tablet, log in. We use Dino as the collaborative software. There's a software out of Washington University. There's a number of collaborative softwares to link them together. We end up picking Dino as the software so that we can link, all the tablets are linked together. They're all in the class. The material gets sent to them. They can see one slide at a time. They can always go back. They can never go forward. So I can release the material to them. If they don't understand it, they can go back, but they're all synchronized with you. Obviously, Dino, like all their tablets, whenever you give a computer to a student, has all the web lockdown and all the other stuff so that they're not on Facebook. We did have an outside observer sit in the back of our class, and they noted, yeah, there's sometimes students are off task, but as soon as you give them a group activity or an individual activity, they're back on. Because the person next to them, the group, the social constructivism, they're socially working together to construct their own knowledge. So they're dependent upon each other. That pulls them right back.
And then the data from that day's class is like saved like through a Blackboard or something?
It's saved through a server, through Dino. It goes out as a Dino file.
Yep.
They can save it as a PDF or output it in another way, but it's output right to them to a server. Their login ID then brings them right to the server, and they have lecture 1, lecture 2, lecture 3, lecture 12. The nice thing I'll mention for deaf and hard of hearing students is the note taker is sitting in another portion of the class. Traditionally, they never see those notes until the end of class. Later, it's a flat PDF. Now, put them in a group, they're seeing the note taker's notes as they're going. They can add to it. They can also, later, a week later, go, how did they do that? You can play back the files. So you can play back my notes, you can play back the note taker's notes, you can play back your own notes, and see the process of it, not just the flat.
Did you have a preference on hardware? Fujitsu over Lenovo kind of thing?
Working was the only thing. Working hardware was no preference that I saw. And I think that's probably what, hopefully many of your experience, it's just got to work. Because when you come in and there's one knot, students, and you hear about it. So I didn't see any preference to it. The character recognition, most of them were writing on it. They didn't use the character recognition to put it into type. They could read their own writing. Obviously, if you can write it, you can read it. And so they didn't use that text recognition feature as much as others may have expected.
When the student is finished writing their own notes, do they send it back to you?
No, they save it as their file. I never see the student's notes. But in this environment, and I've had students do it in the past, and we see have a twinkling that this may be really, the anonymity may be a key piece. Send me notes. They can text me, send me a note, send me a poll, and live. And I'll be looking down and see a little pop-up box and say, can you go over that again? No, let me review that one more time. And flow right back into it. And I'll get the, thanks, I needed that. And nobody has to raise their hand. Because I don't know if you've experienced it in your classrooms, but you get to the end and you say, any questions? And you get the, and everybody starts packing up their notebook. And boy, that person that raises their hand, they feel the scorn of the class. Like, get me out of here! You asked a question. But now, they can ask it anonymously. I can see that poll and I can address it right away. So, that anonymity piece, especially maybe for this generation, especially maybe for underrepresented groups, you're the only woman in a class of 40 engineers. They're all men and they all think they have grease under their fingers and know this stuff by birthright. You might not want to ask the question. Where they probably don't understand it either, but they just make me macho pretending that they do.
Can students bring in their own tablets, or they?
In this environment, we provide all the tablets for them. We have some students on RIT that have tablets, but the majority don't. As I've kind of looked at other places, Virginia Tech mandates 100% of their engineering students buy tablets. Clemson specifies tablets as part of their preferred computer to come in with. So there are some schools that are, if you're going to buy it, you're going to buy this. And you're going to come in it, and we're going to be using this in our classrooms. Now, being not Virginia Tech, and hopefully nobody's from Virginia Tech, they use it a lot freshman year, they don't use it much in sophomore and junior year. So some of the students by junior year are like, why the hell did they tell us to do it? We only use it for 1 year. So I think if you do that, you really got to have everybody working. We have 1 minute, so probably one question.
How do you show the previous slide and then the present slide at the same time? How do you show them together? What kind of software do you use?
It's multi-display launcher. It comes with Dino. So with Dino, I know I have a wonderful support group here from RIT. They can probably explain to you the details. But as an instructor, I hit a button. I hit the button they told me to hit, and it happens, and I'm happy with it, and I just go on. But it's multi-display launcher in Dino. So it's built in to allow multiple displays, which personally from the student feedback, they love. They love the not getting lost and seeing this while reflecting back on, and especially for those that get lost, or I think for our deaf and hard of hearing community, it may be something really valuable. For those who don't know, how do you spell Dino? D-Y-K-N-O-W. There's also out of Washington free collaborative software Dino is not free. Thank you. If anybody wants to pass me a card or talk some more, I will definitely be around.
I forgot to mention at the beginning, if you see a feedback form on your seat or near you, please fill one out for each session that you're here for and leave it in the drop box in the back of the room. Thank you.